Okay, I'm Dr. Cott, Director of MECA. Our STEM session today, STEM Sunday session, is going to be on soft-defined radio and electromagnetic spectrum. So, electromagnetic spectrum basically starts on where? Anybody?
Wait.
On zero. Okay, so and then it goes up to what we're going to be talking about and working with, up to about 10 to the 9th power. So you have kilo, 10 to the 3rd, mega, 10 to the 6th, and what? Giga, 10 to the 9th. That's your cell phones. 2.4, 5.8 gigahertz. Hertz, 1 hertz is as far down as anything goes electromagnetic spectrum. We've gone over fairly thoroughly the visual spectrum. Red down to infrared down to ultraviolet, which is around 400. Okay, 400 to 700. The radio spectrum starts in the music and the audio that starts down around 30 hertz. Okay? Then we start getting it shorter and shorter and shorter and shorter. Okay? Till you're up to 10 to the minus 9th power. Okay? Or 10 to the 9th gigahertz. If you can imagine that in your head. To get a radio license today, we've had 4 teens get radio licenses in the last 2 years. And your first radio license, after you pass the test, you get to be a 2-meter band and a 440 centimeter. 2 meters is 6 feet. So we've gone over this fairly thoroughly, what an antenna is, the kinds of antennas, and what polarization is. So if your wavelength is 3 meters or 2 meters, and that's 6 foot, you need to have an antenna, basically, conceptually and mathematically, half wave. Okay? Or quarter wave, or 5/8 wave. So we'll see how we're going to play with stuff here. All this depends on a lot of ifs and buts, but your wavelengths determine certain issues. Okay, so what we're working on and learning to start with is these little radios here. They're called handheld. A lot of the beginning radio amateurs get these because they're cheap. Last week we went over that. You push this button and you have broadband FM. More than likely you all have listened to that. That's what's in the radio in your car. Broadband FM. Okay. Prior to FM, when I was young, we had AM. AM is not too common today except for the aviation field. And it's common there because nothing obstructs you in the sky, generally speaking. No trees, rain, clouds may. But they can still use AM for some of the aviation bands. So probably the best way to learn some of this is to learn on that which is made for non-learners. Okay, so write down FRS, Family Radio Service. You can buy these for $20 in Walmart stores all over the place. You can use them in your house. Anybody can. They're very low power. They do not do a whole lot, but they sell by the hundreds. Okay. The next one up from there that moves a little bit more into the real world is the GMRS. General Mobile Radio Service. That one takes the license, but all you have to do is buy the license. No tests, no knowledge, just buy the license, and it's good for the house. So my grandkids can use it when they're here. Anybody in the house can use it. So kind of a license for a house. The next one is MERS, M-U-R-S. And we have these radios that are made special for those three things. And then above there, we start with our real world that you live in, of radio frequency. So first comes LVH, low. Okay, that's good. And then VH. Okay, now draw a line there under VH. There you go. Now comes UHF. Next one down, ultra high frequency. Okay, that'd be SHF. Okay, so ultra high frequency for what we're going to be teaching is channel 1 to 12 on a TV set. For many years, that's all we had on TV. Then we move forward, channel 13 up to whatever we can go up to now, and that's ultra high frequency. Okay. So what you have to know when you're here, this gets a little complicated because we just tend to make things complicated. Humans like that. Sometimes for no good reason. But you have to know what a band is, a channel, okay? A channel is for the common folk. Look on channel 10 TV. See the school board meeting going on. Look on channel 16, city council, whatever, okay? So all you have to do is change that there, but the TV people have to be operating at a certain frequency. And you can buy these charts, or you can print them out. The top ones, these are all the frequency. So for the family radio, we have frequencies and we have channels. Then we get to, above that, the GMRS, now they're combined. So that if you have an FRS radio and I have a GMRS in my car, we can talk to each other legally. Okay? But you've got to know what frequency you can use. You can't just click on any channel you want. This chart here goes over a lot of the frequencies. So when you pick up the radio, you're going to have to set the frequency in there. So when we say the MECA Thursday night network, okay, we'll say channel 20, but you've got to look down here, find out what channel 20 is. Back of it is TV channels and their frequency. This is where you have to know what the frequency is. Okay, let me look up here. Channel 20. 462.650. That means in here you'll have to set 462.560 to talk to me. Now what complicates the radio, that's what we call simplex. You're talking to me, then you quit, I talk to you. Most people want to talk back and forth. Or in the radio world, they have a tower somewhere on a hill or a mountain. You have to have two frequencies. So all these radios transmit, they're called transceivers. They transmit and they receive usually two frequencies. You have to transmit on one, and if you want to hear me from the repeater, you have to be on another frequency. So it's not too hard, that part. You've got two channels, you just type them in and you're off and running. The problem is, as you move up, you've got to have some brain power. So, write down a squared plus b squared equals c squared. Okay, what does that mean to you?
It's a triangle.
Right. Everybody out of 8th grade should know that. You're expected to know that. Okay. So in the long one, put 4. Now to hypothesis. Okay. Draw your right angle. Okay. Now draw your angles. Right angle. Okay. Your hypothesis is C. This you should know. Okay. Then you have A and B. So you've got that. Okay. Now make it a little bit longer because that's almost an isosceles triangle. A long one. There you go. Okay. Now put your angles in. Okay. Now the bottom one is put 4, 3. Okay. No, that's okay. 3. Now there's your equation. How long is the other one? Magic. Okay? This is where by 8th grade you must know this. Okay? This is when it's going to get tough from here on. This is where algebra comes in, a little bit of algebra there, and trigonometry. So have you had algebra or trig? Good. You? No? You? Okay. Okay, so erase all that. We went over this probably 6 months ago. And do you remember the circle of units?
No, but I know what it is.
Right. Draw an X and Y axis through the poles. Good. This is called the circle of units. This is a step up from that. It's the same thing. Now, you have quadrants. Draw a triangle in the right quadrant. No, you already said.
Oh, you mean
Same triangle we just had. Okay? So now this is called the circle of units. So when you're going to do this, you make sure you're using a unit of 1. It's just tradition right now. You're going to use zeros and ones, or 90. So 0, 90, go around. 0, 90, 270. All right, 360. Now this is a step up there. That angle is the angle at which determines all this stuff. So give those things the A and B again. Okay. Now starts coming a little bit of advanced mathematics. The line down is what? Anybody remember that? Sine, S-I-N. Got it? Equals sine. The line at the bottom, this is a triangle now. We're talking about that same triangle. We've stepped up from that theory. So, is a cosine. The long angle is a hypothesis. So you can see if you're determining the height of a sail for your ship, the height of an antenna, the height of anything, a star, the moon, you need to know this here equation. And you need to know this amount of trigonometry. Okay. So now, we'll draw it smaller. Put a dot at 15, 30, 45. 15, 30, 45, 60, every 15. Now in the radio world, we're going to call this sampling. The reason we're covering this is to use these programs of soft-defined radio. You've got to have some idea what these things mean. What is a sine? What is a cosine? Okay. Obviously, as you go around that circle, all those things are going to change. Every line is going to get longer or get shorter or whatever. Okay? So, like it or not, this is the universe that we live in. Everything almost depends on that. Your life, the earth, and so on. So, over on the side, draw a sine wave. Okay? Put there you go. Okay. That is your sine wave. So, this here is there. This is there. That's this. Then we're over here to the minus. We're going down. That's called a sine wave. In radio, that is sampling, or in computer. In other words, you only have so much power, like in a brain, in a muscle, and so on. So you only do sampling. You don't do the whole thing. Okay? If it's cheap and easy, you do the whole thing. A speedometer in a car. Okay? But generally speaking, if it takes money or time or effort, you're going to only do certain things. That's called sampling. So the word sampling is important. Okay? So now draw a line down, straight down. Now we're going to start our sine wave here, okay, but it's got to start out here because this is 0, this is 90, okay. Draw a sine wave there. No. Right. This is, we're adding to it. So in a very simple radio, you're going to have just a sine wave. But most things are not simple. When I'm talking to you, it's not simple. I'm talking, we go up, we go down, we talk lots of things. I've got a violin, you play guitar, you play trumpet. It's not that simple. So they have to have a way to make this complex thing work. So what we've done in our world now, okay, is use this principle. Put an I here and a Q here. Yeah. She makes a Q different. So in this program on soft-defined radio, they're going to tell you the I and the Q. Okay? I and Q. And that is those lines there and these sine waves. So this is a simple radio pattern. Then we're going to make it complex by adding something to it. And write this out. If you spell quadrature, Q-U-A-D, quad, U-T-U-R-E. I believe that's right. Okay. This is what they do. Quadrature means you're going to take that sine wave and turn it into more than one waves. So we're only going to talk about 2 waves. So this is where we've talked about before amplitude, AM radio, you vary the amplitude, the high part of it. So show them the amplitude. From here to there.
Here?
That's the amplitude. And that's plus. Down below, it would be minus. You might not want to use it. But anyway, that's amplitude. So AM radio means we're going to take that and turn it into all kinds of little squigglies. Okay, when I say A, B, C, and violin comes in, all that sine wave is going to have all kinds of little squiggles in there. FM is frequency. It's going to change the frequency within that sine wave. So you'll have all kinds of little sine waves there. You got it? More or less? Okay, now draw one line down. Okay, that's the simple sine wave up there. So we're going to take a frequency, let's say, of, what did we just say? 462. Okay, point something something, but this is the important part. Okay, that's your carrier wave. That's the wave that's going to carry all this stuff along with it. Okay? Then you've got to shove all this stuff in there, and you're going to have a bandwidth. So draw dotted lines on both sides of there. And then a distance there,
I don't know what you mean.
a line. That's your bandwidth. So let's say the bandwidth is 10. That means it took you $10. Okay, and if you've got an orchestra with 100 instruments in it, you might have a bandwidth of $100 or 100 whatever. Got it? So you're going to have to know what a bandwidth means. Okay, the carrier frequency. Now, if you look on that side of it, the radio people, sometimes they need to cheat or whatever. So that will be USB, right down here. Upper sideband. They might use that one. And down on the other one, they're going to use a lower sideband. Here. LSB. So in the program on the tablet in here, you're going to have to know where to push the button. So if you want to listen to your favorite radio station that you listen to every morning, okay, you're going to push the button that says what? Wide WFM. FM radio. Okay. So if you want to listen to Alex Hawking maybe on the radio, you'll push the button for LSB. So you've got thousands, if not millions, of choices. And that's why this thing is so powerful for $30 if you learn how to use it. Okay, so those are words you need to know. Quadrature, upper sideband, lower sideband, carrier frequency, bandwidth. You don't need to do anything, just have some idea of what that means when you push the button. So when we get to TV and satellite dishes and cell phones probably, we're going to narrowband FM. We're still in the FM frequency. That's VHS and UHF. We don't move into the super, until you get a satellite dish, okay, and you're talking to the moon or talking to a spaceship. Then you're into extremely high bandwidths. Otherwise, you've got to know that. So Alex is building two antennas. He's building a satellite dish type, what we call parabolic, okay? And he's building what is called the Yagi. It's like this, and it has elements like that. The first part of it is short. We said when the bandwidth was short, you need a short antenna. When the bandwidth gets longer, you need a long one. So to get TV channel 1, TV channel 12 on up, you need two different sizes antennas. So that long pole that he's working on right now is going to have maybe 6 here and 6 there. Okay, now I haven't talked about a very important part of this. This is what is called, in this part of the mathematical world, a phase diagram. A phase diagram. So, draw another sine wave down here. Put the lines in. Okay, now,